Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. We're talking about relations and functions and graphs in Chapter 8. And yesterday, we talked about just regular graphing, how to make a table of values for linear equations. I taught you guys a little trick for the absolute value. Remember, find that h and k, the opposite number. And today, we're going to talk a little bit about relations. This chapter is actually quite easy, but quite important, because all of these skills we're going to be applying later on to functions such as quadratic functions, square root functions, linear functions, absolute value functions, cubic functions. So everything that we're learning will be applied later on. So please don't think, oh, wow, this is easy. Okay, we're done. Yes, it is easy. Learn it, because you're going to have to apply it later on. Now, if you guys remember, a relation is any set of ordered pairs. The input is x, the output is y. In other words, the input, remember we talked about it yesterday, that's the independent variable. That's where you get your domain values from. The output, the y, is your dependent variable. That's where you get your range values from. So there are four ways that they can write relations, okay? Now, you guys may be thinking, wait, but when we talk about functions, yes. But remember, a function is a relation where there's only one y value for any given x. We're going to talk about functions either later today or tomorrow for 8-3, okay? But today we're just going to deal with relations. And this is just any set of ordered pairs. So you can write a relation as ordered pairs. 1, 8, 1, 4, 2, 9, 3, 2. Do you notice how when x is 1, you have two different y values? That's what defines the relation. That's why you know it's a relation and not a function. A function is a set pattern, is a set formula. For example, when you go to the movies, okay, and it's $12 a movie, the function that is inside of their computer is y equals 12x, where x is the number of tickets and y is the amount of money that you owe. If you and your girlfriend go, it's 12 times 2 is 24. So you can only have one y value when x is 2. But in a relation, it's different. A relation is not a set pattern or a set function. Bless you. So one way to write a relation is with ordered pairs. Another way to write ordered pairs is through a mapping diagram. And usually, to be technical, they'll like put this like in a little circle. They'll put that like in a little circle, okay? And a relation, again, this is a relation y. Because when x is 1, y is 8, and when x is 1, y is 4. So these arrows mean, okay, when x is 1, my output would be 8. But when x is 1, my output is also 4. Then you have when x is 2, my y value is 9. And when x is 3, my y value is 2. So you can write it as ordered pairs or as what's called a mapping diagram. Mapping diagrams aren't that common, but you're going to see them like on the SAT and stuff like that. You have a question, sir? Oh, sorry. We're good so far, right? Mickey Mouse. Table of values. In a table of values, you literally have a table. You have your x and you have your y. You can choose any x value you want, plug it in, and then you'll find your y values. So it's just a table. Now, from this table, who can tell me why they know it's not a function? Yes, sir. Thank you. There are two different y's for the same x value of 1. You feel me? Okay. Give me 1 second. Okay. So, last way you could describe a relation is with a graph. They're putting these random points up. Okay? How do I know it's a relation here, though? Sir. Thank you very much. When x is 1, I have a y value here, and then a separate y value here. So I cannot have two different y's for the same x. So 4 ways to write a relation. Not bad, right, guys? So far? Okay. Now, when you have a relation, whether it is a function or not, we've thrown out this word domain and range a lot. But today we're going to hopefully really wrap this up and really understand how to look at any graph just by looking at the graph. And you're going to be able to tell me the domain and the range. Okay? Now, the way domain and range works is it's the valid x values will give you domain, and the valid y values will give you a range. Let me explain what valid means. For example, when x is -3 here, doesn't that link up to a point on the graph? Yes. So it's valid. And what about in between 3 and -2? If I go up from here, does it hit the graph? And 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 here? How about when x is 9? Does it hit the graph? So is 9 valid? Are you with me so far? Yeah? All right. Does that make sense? Okay. As far as the y's go, when I have a y value of 1, does that hit the graph? When my y value is 2, does it hit the graph? When it's 3, of course. When it's 4, does it hit the graph? When it's 5, does it hit the graph? When it's 6, does it hit the graph? So would 6 be valid? Okay. So, when I'm looking at domain, I look at from left to right, because domain is the values of x's. So from left to right, the only valid points here between here and here, would you not say that? So my x is greater than or equal to -3, but less than or equal to 5. How do I write that in interval notation, the way I really want it? Bracket, -3, 5, bracket. Beautiful. That's my domain. Does everyone see that? Domain goes from left to right. Yes, sir. X is greater than or equal to -3. You read from the variable. Thank you, sir. Now the range. The range goes up and down because we're dealing with the y values. So my up and down limits are between here and here, right? So that means y can be greater than or equal to 2, but it better be less than or equal to 5. In interval notation, 2, 5. Does that make sense, my friends? Do you promise? Now, just for giggles, I'll split it in case people are still writing. Over here, okay, on this guy, I'm going to put just different points here real quick. If I give you a relation like this, and it is not connected, you're not going to have a continuous flow like here. You had a continuous flow here because it was a line. And in between every integer, you have decimals and fractions, correct? Here, you don't have a continuous line, do you? So here, the domain and range is a little bit different. The domain. The only x values that are valid here are 1, 1, 2, 3, and 5. The range, the only ones that showed up here were 1, 1, 2, 3, 4, 4, 5, 6, 6, and 7. Do you guys see that? Check it out. This point here, that's 1, 1, 2, 3, 4. So there's the 1 from the domain. There's the 4 from the range. This point is 1. That's not 7. That's 8. That's 1, 8. 1, again, you don't need to repeat the domain. Here's my 8 for the range. This point here is 3, 1. 3 for the domain, 1 for the range. This point here is 3, 1, 2, 3, 4, 5, 6. 3 for the domain, you don't have to repeat it, it's already there. 6 for the range. And then last but not least, this guy right here is 1, 2, 3, 4, 5, 1, 2, 3. 5 for the domain, 3 for the range. It's not continuous. So you can't say, oh, x is between 1 and 5. No, it's not. Do you have any x values for 2? Do you have any x values for between 1 and 2? No. Do you see the difference here, guys? Thank you. Okay. Let's continue. Yes, sir. Sir, if I just taught you that that's how the domain and range are for a relation, why would I not tell you to do it like that?
No, I mean, you do it like that, your answer would be wrong.
Yes, you would do it exactly the way I taught it, hence why I teach it that way. Thank you, sir. Okay, so let us continue. Here, from left to right, what are the valid x values? Oh, that should have an arrow. Check it out, guys. The limit from left to right, I'm starting here at x equals 0, right? And aren't I going to the right forever? So what's my domain? 0, comma? That's right, because x is greater than or equal to 0. Why did I put a parenthesis around the infinity? Because infinities always get parentheses. Why did I put a bracket around the 0? Because it's equal to 0 as well. Does everyone see that? Now, for my range, pay attention. Remember, range is the up and down, correct? I know it's very little, but isn't this graph little by little going higher and higher and higher and higher? And isn't this graph, granted, little by little, isn't it getting lower and lower and lower and lower? So what do you think the range would be? Negative infinity to positive infinity, because it is going to have all of the y values eventually. And I'll prove it. When y is 0, there's a point. Here, there's a point. When y is here, there's a point. When y is negative 1, it's a point. When y is negative 1.5, there's a point. When y is negative 1.75, there's a point. When y is negative 2, there's a point, etc., etc., etc. Are you guys with me here? Because this can be super confusing, or, oh my God, that's ridiculous. Sir, you got it? All right. May I continue? Okay, now here. Ooh, wait, whoa, whoa, what's going on here, Maura? Remember, domain is input, range is output. What's my domain here? 36, 25, 42, 41. Done. Bye-bye. Have a good day. Those are my valid x values. Can I put between 36 and 41 and everything in between? No. Very good. What would my range be? 808, $10.57, and 1182. That's it. Bye. Have a good day. Does that make sense?
Yes.
What's my domain of this particular table? 5, Negative 1. Negative 4. 0. Can I just go like this? 0 to 5? Not in this case because they're individual points. If I had a graph, a line, then yes. But these are individual points. What's my range? 3, 4, 9, negative 5. Very good. Does that make sense so far? Told you, this is really easy. Are we done with this page? Yes. No. Okay. What's the domain? Here. And the range? Negative 3, 0, 2, 9, 23. What's my range? 14, 7, 0, negative 18, negative 99. Domain, possible valid x values. Range, possible valid y values. Good? Excuse me. I have a little bit of a cold and I just can't break this cough. Okay. What's the domain? And what's the range of this circle? Don't look at me like I'm throwing a curveball at you. I'm not. From left to right, isn't that my domain? So I'm going from? No, I go small to large. 1, 2, 3, 4, 5, 6, 7. So I'm going negative 7 to negative 1. Guys, when x is negative 7, I hit a point. In between 7 and 6, I hit a point. When x is 6, I hit 2 points. When x is negative 5, I hit 2 points. Are you guys seeing this? Okay. Now, what's my range? It's between here and here. So my range would be 1 to 7. For those of you that looked at it and were like, what the heck is he doing? Do you see how it's not that scary at all, actually? Sir, thank you. That's a circle. Negative 3 is less than x.
No. You're talking about how to.
You mean how to put it in inequality form, or in set notation? It's called. This is interval notation, set notation. So in set notation, this would be x is greater than or equal to negative 7, but less than or equal to negative 1, and y is greater than or equal to 1, but less than or equal to 7. But these are the big boy ways, guys. That's what you're going to see in the SAT. That's what you're going to see in pre-calculus and geometry. It's good to know both those, so thank you. Great question. Thank you. I'm going to make you write it, just like I said, in interval notation. Would I make you write it in inequality? Maybe for giggles. Maybe I give you an extra credit. Maybe I change my mind and say write it either way. But you got to know both, so it's actually a great question that you asked. Thank you. Sir. It's a bracket because this is a solid circle and the lines it's equal to. If it was greater than or just less than, then you use a parenthesis. So, if I had a graph, and let's say I had a graph like this, but I have an open circle at the end here, and an open circle at the end here, and this is negative 6, and let's say that's 7. My domain in this case will be between negative 6 and 7, because it stops at negative 6, but it's not included. If it was included, it'd be a solid circle, and then it'd be a bracket. You feel me? Thank you, my brother. Great question. Does that make sense? Okay. How about this bad boy? What's the domain here? Very good. Negative infinity to positive infinity. Why? Because from left to right, this keeps going left forever, this keeps going right forever, and it's encompassed forever. You feel me? Okay. Now, here's the tricky one. This is a really good one. What's the range? Fantastic. Negative 4 to positive infinity. Why I said this is a good one, because a lot of people get confused here. And sometimes people go by this one. But you got to go by the lowest one. The lowest possible value of y is here. And then it can only go up from there. Does that make sense? Okay, what about, I'll give you another one. Wait, oh, no, I'm sorry. What about this point? Okay, is that my maximum y? No, because I keep going there forever. Does that make sense, Pablo? Thank you, brother. Yes, sir. Okay, thank you, son. The range is the possible y's, correct? What's my lowest possible y value here that's on the graph? Right here, right, bro? And then doesn't that go up from here forever? And then it goes up to this peak, comes down, but then doesn't it go up forever? So it goes from -4 all the way to positive infinity. Okay? Yes, we're changing this for a second, so I'm going to do it in blue. Totally different. If it was going like this, for example, then it would be negative infinity to positive infinity. Heck yeah. Heck yeah. Good job. Way to go, son. Sir. Why is the domain? Okay. I'm going to erase this blue stuff, okay? Go back. Okay. Little by little, is this not going further to the right, little by little? Do you see that, my man? Little by little, isn't this going further to the left? So that means that from 0 it goes to the right forever. From 0 it goes to the left forever. So therefore, the domain is all real numbers. Thank you, sir. Any questions? Because we're done with this lesson. Sir.
What would it be for the other way to put it?
I don't understand what you just said. So you want to write this in inequality or set notation. X is greater than or equal to 0 or less than or equal to 0. Isn't it? Isn't it equal to 0 and greater than it? And isn't it equal to 0 and less than that? Does that make sense? And then for this guy, that would be y, come on, Moral. Y is greater than or equal to -4. Thank you, sir. Great questions, guys. Anything else? Okay.